Good morning. This is the last chapter included in our textbook. So this chapter is short time scheduling. And scheduling is a management topic for many institutions and included in manufacturing sectors and also in service sectors. So the outline included in this chapter, we can see the global company profile. This is Alaska Airlines. This airlines, and you will see from this company, and short-time scheduling is a big issue. Help them to do an effective job and win the good reputation for Seattle and Tacoma Airport good ranking. And also, we are going to talk about the importance of short-time scheduling. How do we do the schedule? And in this textbook, we give several different strategies to work on schedule. And for some of them is in terms of shortest the time. Some of them is based upon the scheduling efficiency, and also is for a hospital and nurse schedule can be used in using this technique as well. So we also will talk about what is loading jobs and how do we do the sequence loading the job, and talk about what is the finite capacity scheduling and scheduling service. So started with the company profile. The company profile in this chapter, if you read, it is Alaska Airlines. Scheduling is a big issue for them to contribute to Seattle and Tacoma Airport for good ranking. And I have been in Seattle a couple of times. I know this airline, Alaska Airlines, and have a big terminals and using this airport. And Alaska Airlines not only provide a service to Alaska, and actually provide a lot of service to the entire United States. And this airport, so it's the 15th airport, biggest airport in the U.S. Because they have the winter season, a lot of continuous rain, and also the bad weather can impact the scheduling on time. So, for example, Chicago is also a big issue. Denver Airport. These are all impacted by the bad weather and storms. So in this case, how they can change the schedule quickly, how they can load the people to the right airplane, and that's the biggest problem. So they use the good technology or latest technology to reduce cancellations and delays, and cost or save around $18 million per year. And when we do schedule, actually, the software for scheduling using a lot of mathematical modeling and use highest algorithm and very cool algorithm. But we do not really teach algorithm in this class. Instead, we are going to teach the techniques already generated from the algorithm. We can use it directly. We just follow the sequence 1, 2, 3. What are the steps we can come up with the schedule. So in this chapter, the learning objectives include explain the relationship between short-term scheduling, capacity planning, and aggregate planning and master schedule. Schedule very much related to all of the rest of the topics. See, capacity planning, and also aggregated planning and master schedule. So what are the relationship? So we also introduce Gantt chart and draw the Gantt chart loading and a scheduling chart. Gantt chart, I think Microsoft project software, they provided this function. So in our class, because the scheduling is only one chapter of this class, I do not have the time to cover software. Sorry about that. I think probably 31, that class is a technical project management. They spent more time about drawing Gantt chart. So also applies assignment method for loading jobs. As I said, scheduling a job involves a mathematical algorithm. We didn't teach algorithm. Instead, we are going to use the algorithm result directly. The algorithm result, that's the assignment methodology. So we are going to learn 1, 2, 3, the kind of like methods to see how we can assign the jobs to different workstations or to different variety of peoples. So name and describe each of the priority scheduling rules. We have first come and first service, and also we have earliest kind of due time strategy, and other strategy also use shortest processing time. So we are going to practice. So, and also we are going to practice the Johnson's rule. So Johnson's rule, I think in one part it is simple, but if I do not use the example to explain Johnson's rule, if you only read the textbook, I think it will be hard or really challenging. So we are going to have in-class practice about these kind of like things, priority sequence rules and Johnson's rules, and define finite capacity scheduling, and also use the cyclical scheduling techniques to plan the staff scheduling for doctor's office or clinic office, some kind of like a service. So the major goal of scheduling is to allocate and prioritize the demand to the available facilities. For example, we have 2 machining centers, but we have 1, 2, 3, 4 jobs. How can we plan the jobs and assign the jobs to the 2 available working centers? So you need to find out, okay, what is the highest priority? And depending what kind of like a rule you use to define your highest priority. So sometimes people use first come, first service. Sometimes people use, I want to use the shortest processing time. And also we can use other rules to make the minimum like cost. So different rules may lead us to use different assigning strategies. Obviously, short-term schedule is important. So it's going to provide a competitive advantage in the market. And if your scheduling is effective and efficient, and then we can provide a good, faster movement of goods through a facility. So that means we can process faster, we can reduce the cost, and also sometimes we deal with the capacity. So we already, the current facilities, all of the machines, all of the technicians, they are all full. At this situation, this is a capacity issue, and additional capacity resulting from faster throughput improves the customer service, and through faster delivery. And the capacity is closely related to schedule. And the last one, it is a good schedule resulting in more dependable services. And that means, okay, I will provide the customer with the continuous service or just the in-time service without any kind of like stock out issues or without any kind of like short of technician issues. I mentioned to you probably already a few years ago, I think in 2004, I had a travel with Delta Airline from Detroit, from Cedar Rapids to Shanghai in Beijing. That's the international travel. I have a very good schedule according to my travel itinerary, because the taking off at Cedar Rapids is 11 or 9 is in the morning. I only have 1 hour or 1.5 hour connecting time in Detroit airport. So it's really a good kind of itinerary. I already kind of like boarded to the travel to the airplane from Detroit to Shanghai. But after kind of like 1 hour, we still couldn't take off, and then we were removed from the airplane. So then after a few kind of like 30 or 40 minutes later, they reboard all the passengers to the airplane. And then we have been waiting and waiting, so it still couldn't take off. And finally, the crew member, so the pilot and also the crew attendants, they were removed from the airport. That was July 4th or July 3rd. It's right on the kind of like a national holiday. And then the reason they said, oh, because we wait for so long, and then if we let this crew member continue flying, and then they will go beyond their hour limitation, because they only can work 13 hours per day. Otherwise, they will be tired, cannot make sure the safety. Yeah, that's reasonable, okay? And then they said, oh, we need to call and to find out pilot, and then to find out a crew member to fly for this airplane. So, and after 1 hour, they said, oh, totally, we have to cancel this flight because this is a holiday time. Nobody can come to to make this flight possible. So we were all removed from the airplane, and then we were provided vouchers, provide whatever the kind of like a lodging service and a meal service. This costs a lot of money, right? And also, how about the customer? Are they happy? No, I was totally, thrown off my schedule. I already called somebody over there, so you please pick me up at the airport in Shanghai. I have to contact and say, oh, why are you calling me? You are in the airplane. I said, no, sorry. And you have to, play by ear, because I don't know when the flight will be landing in another airport. So that's my final destination. How about other people they need to transfer? So that will be a big issue. I'm saying this is the totally about a scheduling issue. This is the management scheduling and end up with the cancellation. And for airport, it is very, very important for their schedule. I have another traveling experience is in Seattle, and my flight was from Seattle to Beijing, and then because their engine, they need to replace the engine for one small part, and then they found out, oh, I do not have the engine spare parts in the airport. They need to call from Atlantic and then send the engine part to Seattle, and then they need to do the test. So totally 7 hours delay. That's really frustrating. So these things are all about scheduling, and end up with the customer not happy. They will not give a good rank. And for scheduling decision, so who I really care about And here, airlines, hospitals, and even I think like entertainment, like sports industry, and also universities. Universities need to consider the scheduling and also the classroom like capacity, and also the university rules. So Monday, Wednesday, Friday class, or Tuesday, Thursday class, these all have to consider. So, and not only manufacturing, of course, they need to produce parts according to their schedule. Scheduling deals with the timing of operations. And the main idea of scheduling is to allocate and prioritize the demand from the forecast or from the customer requirement. There are significant factors in scheduling. We will, hear these terms such as forward or backward scheduling, or finite and infinite loading, and what are the criteria you want to use when you scheduling the jobs. For forward and backward schedule, so, and if you look at this small kind of like diagram you see, okay, forward scheduling starts as soon as we know the job requirements. It's going from this moment going forward. And as soon as you know the kind of like what is the job requirement, how long you want to process the job, and keep going. And it's going to produce a feasible schedule. And because we do not really look at the due time, and you are going to make the feasible schedule, that means, okay, once you make the plan, for sure you can implement the plan. But the problem is, and sometimes we cannot guarantee the due time. And for example, the first come and the first serve. So the latest come does not mean they always have the latest kind of like a due time. So, and the forward schedule cannot really guarantee meet the due time. Frequently result in backup of the work in process inventory. That means, okay, a lot of like they are waiting for processing. So this is forward. And for backward scheduling begins with the due time and then schedules the final operation first. They will go backwards. And so this we want to. So they always consider, oh, I want to make sure the job is meeting the due time. And in this case, and a resource may be or may not be available to accomplish the schedule. That means resources means, okay, your capacity is not enough. So maybe we see the limitations of the physical capacity. You do not have so many classrooms to hold out of the students. Or we do not have so many machine tools to process all the required components. And or we do not have enough like working personnel or technicians or flight attendant or pilot to do this. So it is the due time, and you consider in consideration, but resources may be a problem. And quite often, these two approaches are combined together to provide a trade-off between the capacity constraints and the customer expectations. We need to look at the balance. So for finite and infinite loading, so loading means we want to assign specific jobs or tasks to specific workstations, to specific people, and at a certain time. Finite loading means, okay, when we assign the jobs or the work to certain stations, to certain personnel, we already consider the capacity limitation. So with this, keep in mind already. So you consider the capacity limitation, and we can get all the work done. But the disadvantage is we cannot guarantee we all meet the deadline. If the capacity is the problem, we have to generate a backlog. That means some of the work have to wait and until the facility is available, until we have enough technicians to work. Infinite loading and is on the other way, does not consider any capacity. So we just say, oh, we will make sure to guarantee to finish the job at a certain time, and all the due times will be considered, all the due days are met, and if we do not have any if we have capacity difficulties or limitations, and then we have to think of a way to increase or improve the capacity. You have to ask for maybe temporary worker, or rent other people's facility, or rent the machine, or extend the working time to finish all of the required jobs. So this is the difference between finite and infinite loading. For scheduling criteria, we use the minimized completion time, okay, and also the maximum the utilization of the facilities, and how about try to minimize the WIP. WIP means work in process inventory. Reduce the inventories in the process, and also to reduce the customer waiting time. These can all be the criteria to, use this criterion to schedule, make the schedule better serve customers' need, or make satisfy the customer needs and make them happy and get more business later on. And these are the kind of three tables in our textbook. They talk about three different process. Remember in the previous chapter, we talk about a process strategy. We have process focused. We have repetitive, process. We have also kind of a product focused process. So, and the fourth one is customization process. For customization, we didn't really use any kind of a scheduling kind of in this chapter. But for the rest of the three kind of a process, and they pretty much gave you the idea how do you consider about scheduling. For example, the process-focused facilities, scheduling to customer orders where changes in both the volume and the variety of jobs are frequent. So basically, we use due time focus, like the bridge project, or like a building project, a construction, and they use due time focus, and also with the loading refined by finite loading technique. So this is kind of like a combine of loading, finite loading, and finite loading and due time strategy. For finite loading strategy, we said that means we have to consider the capacity, but the due time and is sometimes we already, so here is already considered a due time, and this one finite loading strategy, we said due time sometimes is the problem, but in this type of situation, we have to combine them together. Okay, consider both. Consider due time and consider your capacity resources. And if you do not have capacity resources, and then either you recruit more people and extend the working hour. Otherwise, you need to talk to the contractor. Say, I need extended time, and write this in the beginning of the contract. So budget is very important. When you make the budget budget should reflect your reality, and then you will reduce problem in the end. For repetitive facilities, and then finite loading with focus on generate a forward working schedule. So just-in-time techniques are used quite often. For the next one, it is product-focused facilities, continuous process. They use finite loading and also on forward schedule as well. So, and these are the three types of process strategy, and considered with together about with the loading or scheduling strategy. For input and output control, this is saying sometimes, if you book your schedule too full, so actually you cannot finish all the booked schedule, and the incoming material waiting for processing will be piled up and waiting for process. This is coming in is too much, too many, and then it's going to generate a very crowded situation, and it's going to overload the machine, overload the technician, both. People, you cannot make them overload. If they are overloaded, the people will get overwhelmed and tired. If they are tired, it's easy to make like a mistake, quality problem, and is an issue as well. So overload will generate fatigue and machine fatigue. Then people say, oh, I'm so busy, I don't need to do the preventive maintenance. That's wrong. Okay, you need to have enough time to still do the preventive maintenance. That's why do not overload machine, do not overload people. How about underloading? Underloading is to say, oh, I finished all my work. I'm waiting for somebody to send work for me to continue to work on. So if machine and people, they are waiting for incoming materials, that means too much idle time. You have a lower utilization rate. So also be a problem. And the input and output control can provide the managerial action to resolve the scheduling issues, can be maintained using a whip cards that control the scheduling of the batch. So the whip, that means it's kind of like a Kanban card. Okay, after you finish all of the work, you return this card to the people who supply the job. Say, I finish up all. I'm waiting for the next one to send the material to for further processing. Here is the table of input and output control example. Here's a CNC or DNC machining center, and if you see in this week is June 6th, June 17, June 13, another week. So third week, fourth week, and the seventh week. So each of in the table you see, I want you to see the two kind of like lines, rows. This row, cumulative deviation. How do we calculate the cumulative deviation? So for example, in week June 6th, the planned income, it is 280, but the actual income is 270. There is a difference. So here is say, okay, the actual input is less than the planned input. there is a negative, so this is the deviation. But when you see cumulative deviation in the second week, so here is a planned, it is 280, but the actual is 250. So there's only 30 kind of like a difference. But since this is a cumulative, we need to add the different deviation from the first week, which is 10, negative 10 and a negative 30. That's why you see it is negative 40. And for another week, and in June, in the week of June 20th, now we see no deviation. No deviation, and then the cumulative deviation will be exactly same as the previous week. So negative 40. Do you see what I'm saying over here? And in the fourth week, now we see, okay, and the actual input is 285, but the planned it is 280. So there is a positive 5, and then positive 5 plus a negative 40. Now we have a negative 35. So cumulative deviation, not just look at 1 week. They look at, so first week, and then second week will plus the first week, and the third week will plus the previous 2 weeks, and the fourth week will plus the previous 3 weeks deviation. And for the output, same. They also have the cumulative like deviation. Here, the first week it is negative 50, and the second week it is negative 50 as well. So end up with is negative 100. And the third week is 100, kind of like a 50. And then every week add up together is negative 200. So they said the cumulative change in backlog over here, this is 0 because they have, I use another different color of the pen. Here's the input. This is the output. Negative 270, and input is 270, and the output is 270. That's why there's no backlog. So how much you coming in, process, and send it out. There are no kind of like a backlog. But in this week, second week, 250, and here it is 200. Second week is 200. Oh. And in second week, 250 is input, and here it is output is 270. Now they have the backlog, it is negative 20. So, but in the third week, so reduce because 280 here is 270. So, and they only compare the input and output. Input and output, here it is output. And this week, change it is 0, and here it is 15. And now, because this one is larger than this one, it is 15. Positive 15 and negative 10 now end up with positive 5. And they used over here, it is cumulative deviation. Cumulative means you keep adding the previous week, always adding the previous week. It is the this calculation, we have seen it several times. So, and they tell you how to calculate the cumulative change in backlog. That's 270. 270. Here is 250 and 270. That's why it's, and totally in the end it is 5. Gantt chart. You are all familiar with this Gantt chart. I think sometimes when you write a project report, you need to tell, okay, when I'm going to finish. So in 2 or 3 weeks, I need to write the proposal in the beginning. And in the middle of the process, I need to do like a prototype or design, and then I need to test. So, and the Gantt chart shows the loading and the idle time of the departments, machines, and the facilities. Also, give you, the visualization when you can finish the work. How long, how many days, weeks you have to finish specific steps or procedures. And it's a good visualization charts and help us to monitor the work process. This is an example of the Gantt chart, and now we see this different color. The yellow color representing it is unscheduled. That means you still have some kind of like open time. And then the light blue color showing, okay, so this is the job already signed. But the orange color with the cross kind of like symbol, that means the center is not available. You can make some kind of like this is not available. Probably the machine is breaking down, or you need to do some preventive maintenance, and give us an idea. Okay, this is the whole week: Monday, Tuesday, Wednesday, Thursday, and Friday. This is one type of like a Gantt chart. Here's another type of Gantt chart. This Gantt chart quite often used in for students to write their report and plan their schedule. Here is saying, okay, and this symbol started from the left as a corner and a solid line, start of activity. So this is the end of the activity. Here it is scheduled activity time allowed. So if you use this symbol, you can see, for A, totally you need 5.5 days. Okay, it's already scheduled. And the solid kind of like a bar is showing, okay, here I'm already finished and about 4.5 days. But this line, this dash line means, okay, this is the current time right now. And according to the Gantt chart schedule, I should kind of like reach to the end of the 5 day of the work. And look at this moment, you see, activity A is a little bit behind the schedule. And I'm saying it's very close. Okay, for activity B, this is showing already finished. So starting and end point, that's the schedule. This is the real activity. It's done already. But for C, and C is saying, okay, here we are right over here, but and the real activity is already moved to some kind of like 2 days later. So that means it is before schedule. And this is the Gantt schedule chart. Tell us when to start, when to end, and what is the entire allowed activity time, and how you compare with the schedule. Are you right on time, or a little behind, and need to catch up? So another one we talk about is assignment method. So we said special class of linear programming models that assigns tasks or jobs to resources. I said, we don't want to teach you any mathematical linear programming modeling. So we just try to use the result. And how we use the result, they give you sequence or steps. We follow the steps, and then we can assign the job to different kind of like machines or technicians. And our objective is minimize the cost, or makes the shortest, minimize the processing time. And here the assumption is only one job or one worker is assigned to one machine or one project. Here's the example. It's a printing kind of like a shop. They have the job number is, this has the job, printing job R34, S36, T, and 50. They have 3 types of machines, A, B, C. If you use A to do job R34, it's going to use $11. If you use B to taking care of job R34, it's going to cost $14. If you use C, and then it's going to cost $6. Our idea is to assign R34, S66, T50 to A, to B, or to C. You don't know which one you are going to assign at this moment. You think, oh, how about I assign this one to C? Oh, it looks like this is a minimum kind of like a cost. How about others? You also have the minimum. This is the $7. It's not really much. But if you look at only kind of like a $1 difference, but here if you have if you see this is a $2 difference. The goal is to minimize the overall cost of job R34, S66, and T50. So here it is the assignment method. I think you don't want to read this so much, because when you read, you still don't know what's that. So let's say read the first one. Okay, our goal is to assign the 3 jobs to A, B, and C. Okay, create 0 opportunity cost by repeatedly subtracting the lowest cost from each row or column. If you continue to read, draw the minimum number of vertical and horizontal lines necessary to cover all the zeros in the table. What are you going to do? If the number of the lines equals either the number of rows or the number of columns, and proceed to step 4. Otherwise, you have to repeat 3. So, and I think I want to, skip this, the reading the assignment method. How about we start with the example? Okay. So the example. Create 0 opportunity cost by repeatedly subtracting the lowest cost from each row and column. So from here, this is the first step. And subtract lowest number and from each row or column. Here we subtract each row. So this row, what is the lowest number? You need to look at here, and otherwise you will lose the track. What is the lowest number? 6, right? If we subtract 6 from this row, so here will be 5. This will be 8. Here is 0. And how about the second row? 8 is the lowest number. If I subtract 8, this is 0, and here's 2, this is 3. Similarly, I'm going to subtract 7. So now this is 0, here is 5, here is 2. Keep doing this. And also subtract the lowest number from the columns. And now you see, and from A, this one, the lowest number is 0. If you subtract the 0, it's still going to be 502, correct? And how about this one? If you subtract 0, because that's the lowest number, it's still 0, 3, and 0. But the second column, the lowest number is 2. If I subtract 2, now it's 0, it's 6, and 3. So the first step is subtract lowest number from each row and each column. And the next one is using the lines to cross all the zeros in the rows. So, and they said because only 2 lines are needed to cover all the zeros, the solution it is not optimal. What do we talk about here? Let's go back to see the strategy. Draw the minimum number of vertical and horizontal lines and necessary to cover all the zeros in the table. If the number of lines equal either the number of the rows or the number of columns, and then you are going to skip the third step. And in our case, we have 2 lines, correct? We have 2 lines to cover the 0. How many rows? We have 3 rows. How many columns? We have 3 columns. So that means, and here is the number of rows is not equal. It's not equal to the number of rows or the number of columns. We need to go to step 3. So subtract the smallest number not covered by the line from all other uncovered numbers. So let's see how do we return to step 2. Go to the next one. Okay, we have 2 lines to cover the zeros, and then we need to conduct step 3. Step 3 is the smallest uncovered number is what? It is 2. And if this is the case, we need to, the smallest uncovered number is 2. So this is subtracted from all other uncovered numbers and added to the numbers at the intersection. So here, these 2 not covered. You need to subtract. When you subtract, this becomes 0. Here it becomes 1. And they also said you need to add this number to the intersection of the line. Here is the intersection, 3. And then if you add this number, now it becomes 5. So now we see in each of the lines, each of the columns, we have 0. We have 0. We have 0. And here you all have zeros. So how about the next one? So we have 3 lines to cover the 0. 3 lines, the number of lines equals to the number of columns. So right now, that's the last step. We can assign the jobs. How to assign the jobs? Look at this R34 in this line, and this one, it is the 0, correct? And assign this R34 to the 0. 0 according to it is C. So assign R34 to printing machine C. And if you assign this to C, and how about obviously S66 should be A or B, because so A and B they are 0. And for T50, they have two options, either to A or either to C. But because we already assigned R34 to C already, so you need to cross this one. So this one, A should printing machine A should do the work of T50. So, and then after, if this is A, B should be this one. You see what I'm saying? Matching up situation. So only assign the job to the zeros. R34 only have one option of 0, which is A, correct? But S50, they have two options, A or C. And then if R34 goes with this one, and we cannot use this one, so T50 have to combine with T and A over here. So if here, and for B, it is the leftover, and B can go with A or B, but because we already matched A with T50, now B should be with S66. So in the end, we have it is R34 is C, and S, and 66, which is B. And T50, so this is A. So if you use this and assignment, we can figure out what is the total cost. So the total cost will be here, 6. And this one, it is 9. And the next one, it is 10. 6 plus 10 plus 9, totally is 25. Using this strategy can help you to get the minimized cost. Using others, if you sign in, okay, this R34 with A, or this one with B, and this one with C. So let's say it is 11 plus 10 plus 7, so it is $28. So, and I said, we only use the methodology generated from the algorithm, and you don't have to worry about the mathematical algorithm. Algorithm is already being applied in this assignment strategy. And the next one, it is a sequencing job. And the sequencing job is to try to specify the order and in which the jobs should be performed at the work centers. This is used everywhere, used in operation room. So how the surgery can be done. You have only 1 or 2 rooms, but you have 10 people are waiting for surgery. And also you have machines, okay? Only 2 or 3 machines, but also you have to follow the sequence, which one will go first. And the priority rules, and used to deploy or sequencing the jobs, we have first come, first serve, shortest processing time, and earliest due time, and also longest processing time. And we need to use this criteria to make the judgment which sequencing kind of like rules will generate the best result. So the criterion we use over here, it is completion time, facility utilization percentage, and how many number of jobs in the system. And also we use the due time to make the judgment. Here we generate a flow time. this flow time is the new term, and used to make the judgment of performance criteria. Flow time, it is the time between the release of the job to a work center until the job it is finished, okay, including the waiting time. So, and we have this kind of like formulas to calculate or to quantify the average completion time. Average completion, it is the sum of total flow time divided by the number of jobs we completed. Utilization, it is, so you always compare the real job processing time divided by the total flow time. And then average number of jobs in the system, this is the sum of the flow time divided by the total processing time, work processing time. And also we have the lateness calculation. They give you the formula. I think probably we don't need to use the formula because the formula sounds kind of like, okay, it's hard to understand, but we can use an example to let you see how to consider or calculate the job lateness time. Here, the lateness formula is 0 and compare with yesterday plus flow time minus like a due time. Suppose today is 20, day 20. Yesterday it is 19. And the due time it is tomorrow. So they give you 0, and then it is 19 plus 1 minus 21. And then obviously maximum is 0, so there's no late time. And they give you another example here. And the due time, it is 2 days late. But I still think another solid example giving a few options. Okay, we can calculate the due time or count the due time, help you to easily understand how to use this formula. Here it said they have 1, 2, 3, 4, A, B, C, D, E, okay, like jobs, but we want to use the 4 rules. 4 rules: first come, first service, earliest, latest, longest process time, shortest process time, and also earliest due time. We use this to sequence A, B, C, D, E. So I have a Excel table in this week. We cannot finish, that's okay, but we can, start this, and then we can finish next time and submit on Thursday. Oh, here it is. Today's Thursday. Submitted on next. This is here. Sequencing jobs. We have the job A, B, C, D, E, and the work processing time, it is 6 hours to a day, or I don't know, hour or day. So 6, 2, 8, 3, 9. This is the real time you need to finish A, finish E. Okay, the job due time is, so if it's, you need 6 days to finish, and it's going to be due 2 days later. Like the first come and the first service, whatever the time we have, so A comes first. So we can just say we use the natural sequence A, B, C, D, E. Flow time is the same. When A is working. B, they need to wait until A finished and B can start to work. So flow time, it is the flow time is the working time plus the waiting time. So waiting time is 6 hours, and then in the real processing time it is 2. Okay, you can consider how about days. Okay, so working time is 6 days for A, but for B you have to finish. You have to wait for A to finish and then to start. So flow time is a cumulative time actually. So C has to wait until A and B finish and then to start the C. So for C continues to work. Of course D it is and waiting as well. And D have to wait for A, B, C finished and then start the D. So, but the total flow time equals to this. And the total processing time here is this. Then we need to consider what is the late time, okay? For A, obviously there is no late time. Because late time it is job due time is 8. Now you have it is due time. I can copy this column over here. So 6 is less than over here. Okay, 8. Now the first one, late time is 0. Second one, late time is 2. The third one, late time, it is finished by the time of finishing C is already 16 days. So it is 2. And here it is 4 late time. And the next one, it is lead time is 5. So the total lead time sum, right over here. And then now we see the 3 kind of like a formula. So the formula is, that's the performance criteria. So average completion time equals to sum of total flow time divided by the number of jobs. So we use this equals to total flow time divided by the number of jobs, 5. A, B, C, D, E, 5 numbers, right? So, and it's 15.4. Utilization, efficiency. So here it is the, if you look at the formula, it is processing time divided by the total flow time. So equals to 28 divided by 77. And if you use a percentage, and we can make this 36.36%. Average number of jobs in the system equals to, look at what is the formula over here. Average jobs, number of jobs in the system is sum of the total flow time and divided by the processing time. So equals to 2.74. So that means in average, there will be 3 jobs in the system. 1 it is working, 2 they are waiting. Okay, 1.7 is waiting. And job lateness is 13 divided by 5. So here it is the first kind of like first come and first service. So for shortest processing time, and you need to look at which one it is the smallest one. Because here 2 it is the smallest one, and this one will go first. B is going first. So the job process time is 2. And D, it is 3. And then next one, it is A. A is 6. So 6. And C, it is 8. And E, it is 9. And pretty much we are going to do the similar things over here. Okay, you need to, figure out what is the flow time and then do the calculation. Actually, I provide all the formula over here to save some time, but I won't do it right now, okay? So time is up. I'm going to stop over here. Next time we finish all of the rules. So we have the shortest processing rule, early due time rule, and the longest processing time rule. So, and then we are going to summarize. These are simple, easy to understand, but it's useful. Give you kind of like an understanding what sequencing rule will provide you the good performance. Okay, I'll stop over here, and then next Tuesday we will continue. I think next Tuesday I have I think Johnson's rule is difficult, even though it's kind of look at it, it's simple, but you need to be very clear what you are doing. And then the next table, it is step scheduling. We are going to practice together. Hopefully we can finish on Tuesday. And then I'm done with all the semester. So Thursday, you can review, I put the online test, okay? So save whatever you have at this moment, we'll continue to work on, okay?
Is the test going to be like the Thursday next week or over finals week?
It's going to be Thursday, Friday, Saturday, and Sunday.
You get all that time to do it?
Yeah, you get all the time to do it. But it's 75 minutes.
Okay.
Okay, and the second part of the exam, it is problem solving. I gave 2 Excel tables. You need to use Excel, use the computer, and I think I give 30 minutes to 2 problems, okay? And the work content will be very similar to what we practice over here, okay? And make sure you really do, I know you are here to, follow with me with the in-class practice. And if you forgot how you do the procedure, you need to go back to review.
You also submit what we have for class.
Today, no. Okay, just wait for tomorrow, for the next time we finish.